Here we go. Nope. That's really cool. Here, I'm going to make sure that it's not.
I sign in as a guest, right?
Yeah, that should be fine. That's what I'm attempting to do. The stream over is the URI guest, so we'll see how that works. And so just so you know, this is I'm doing the live stream of this because there's a couple folks up in Providence that wanted to join in, and so hopefully they're able to get on. If you're in Providence and you can't get on, please just send me an email and let me know. But watch your language because this is going out on YouTube after the fact. So we've got that.
Audio through.
Yeah, it's the audio's through my laptop. So essentially, I'll be doing a screen share, and so they'll hear everything we say. So yeah, and then unfortunately I can't stream this, but if you want stickers, I feel like a pusher every time I have one of these events. We try to push the Roadie Rstats stickers. So if you want some stickers, come take stickers, please. Let's see. We'll wait another minute or two. So did you all got R&R Studio installed?
Yeah.
And up and running?
Yeah.
Perfect.
So are we going to connect through Roadie Rstats to like the data and stuff that we need?
Yeah. So we can follow along. I'll once I get into that, I've got all the materials up on Roadie Rstats on GitHub. All right. So before we get going, we'll go ahead and do a round of, since it's a small group, a round of introductions, and we've got some new faces, which is great. And there may be one or two other people that show up throughout later today. But so my name is Jeff Hollister. I'm a research ecologist with the U.S. Environmental Protection Agency. We have a lab that's over on Bay Campus, and so I'm also adjunct in Natural Resources Science Department, and also a coastal fellow a fellow at the Coastal Institute. And so Roadie Rstats is a program that's been supported by the Coastal Institute, and so they're the ones that help us get logos and buy nice stickers and all that stuff. And so, sort of in my role as a fellow at the Coastal Institute and adjunct faculty, I decided we'll try to start our study group. And so we did. We started it last last year in January. We had an event, and then had meetings throughout the year. We met a couple times this summer, and then we did a data carpentry workshop 2-3 weeks ago. And then so this is our first meeting for the semester. And so what we'll be doing is we'll have 2 meetings a month. One meeting will be kind of like this one, where we have a topic that we're kind of going to go over, and somebody will have, for the first few, it'll probably be me. I'm hoping to get other people to do some presentations. So we'll have one of those, and then the second meeting is sort of a question and answer kind of thing. Say, hey, I've been trying to do this, and I got stuck on this point. I can't get my data read in. How do you do this kind of thing? And so it's sort of that'll be free form. There won't be any materials prepared, and it's bring your problems, and we'll, as a group, try to help come up with answers to those. So that's me, and then I'll let Ann go next.
Yeah, Annie Q, and I work at EPA also, as a judge's office mate. I'm learning our studio, and very new. I keep trying. It's like my, I try it every year, twice a year, 3 times a year. It's starting to stick, but I haven't invested the time like I should. So I do research ecology, marine, estuarine research.
Hey. How are you? Good. We've just started introductions. So yeah, we'll keep going.
Hi, I'm Liz Brennan. I'm a PhD student here at URI in the Muslim Bacterial Lab in biology. And I've slowly been introducing myself to R, I guess. Kind of the same situation. I'm trying to pick it up in my non-existent spare time of grad school. So I figured this is a good way to learn.
I'm someone that I would say, my sister things biology and sciences. This baby, you know, so I'm here today.
Great. Great. Graham, we'll let you.
Yeah, I'm Greg Forrester. I'm a professor here. I'm here because I tried to learn R a few times, but the 2 things that make it hard is that I'm middle-aged and can't remember new things. And I always feel like then I just fall back on things I already know. But I need to learn it. I'm going to try it.
We'll drag you along.
And I am Innocent, master's student, medicine department. This is my first time to art, so I'm open-minded to learn as much as I can.
Well, and we got you guys installed and set up like 10 minutes ago, so that's the most important first step. I'll let you introduce yourself.
Hi, I'm Jenna Morton-Aiken. I'm a PhD candidate in writing and rhetoric, and I'm using metadata in the archives for my dissertation. So I'm just starting to very beginning of learning R, so I'm very excited to be here.
So I apologize for the examples that we'll be using, because most of the example data sets will be all environmental and ecology. And at some point, we should talk. We can try to figure out to have a session or 2 on kind of text stuff and digital humanities. And there's a lot of really cool stuff happening in that realm. So yeah, so great. It's great to have everybody here. I don't really want this to be me being a talking head up here and say do this, do that. So questions are great. If you have other things that you want to see as we're going through, then that's good too. So this is going to be a really sort of loosely organized thing. I've got materials and we'll go through those, but feel free to interrupt. And then since we haven't officially finished the introductions, we'll let you introduce yourself.
My name is Ryan Chaffee. I'm in the Masters of Environmental Science and Management program. Last semester, I'm in Stats 576, where we're doing a lot of R, and
Great, thanks for coming. And then just so you know, we are streaming this on YouTube, and so there's a couple folks up in we're going to get billions of hits on this thing. There's a couple people up in Providence that weren't able to come down, and so we decided to set up the live stream. And then the recording will be around after on YouTube, so you can go and take a look at that in your spare time if you want to hear me drone on. So the first thing, how much? So I know 3 of you are brand new. Graham, I know you were in the data carpentry. You guys have experience. You have any experience with R?
Very
And then you and I emailed back and forth, didn't we? Yeah. So great. So what we'll do before we get started with the lessons, we'll just do a quick rundown of the basics. And then this is Chuck Labash, the famous Chuck Labash, and I'll let Chuck introduce himself.
I'm Chuck Labatt.
And where do you come from?
I just came from over there.
Yeah.
I'm in the, I'm with the Environmental Data Center, Department of Natural Resources Center.
And Chuck's you were at the data carpentry, so you got a little bit of background. So we'll start with a little bit of some of the basics. And I'm going to breeze through those pretty quickly. So if you guys have questions as we're going along, feel free to stop, and then we can address those as they come up. But I'll try to remember to, when I'm showing things the first time, to at least introduce them so you have an idea. So the way we'll be doing all our work is going to be through RStudio. And so we need to have R and RStudio installed. And so once you fire up RStudio, it's going to look kind of like this. Oh, and Chuck, so you know, this is being streamed on YouTube, and the recording will be available later. So watch your language.
Are we supposed to be following along here?
Yeah. So probably the best way to do this is to follow along. The lessons, I have a couple of little challenges that'll give you some time to work on the problems yourself. But as we're going through, it's a good idea to follow along. And then if you get stuck with anything, again, just raise your hand. So first thing we need to do is have RStudio up. And when RStudio is up, it's going to look something like this. And so we'll have RStudio has these 4 panes. So what RStudio is it's an integrated development environment, or an IDE for R. Essentially, when you start RStudio, you're starting R. And so to see that, this is the console pane down here. That's where R is actually running in RStudio. And so we can do, we can type commands in here. So 4 + 5, and return 9. You can do it as a 11 - 10. So this is the console. This is where R is actually running. This pane up here, this pane is going to be, this is the source pane. So this is essentially a text editor. And probably the way we'll be doing most of the work is we'll write stuff in the source pane or in the text editor, and then we'll send those commands down to the R console. And the way you can do that is, so let's type a function. So this is the ls function in R. Essentially, it means list my objects. But there's a couple ways to get the functions from here down to here. One of them is you can hit this run button. And so it will run, if you have anything selected like I currently do, if I hit run, that's going to send that command down to console. If you don't have things selected, but you're just on the line, see how the cursor now is just on that line, that'll send that current line. And you can see it's essentially, it's returning nothing because I don't have any objects created yet. The way you'll see me do it often is with Control Enter. And so whatever line I'm on, if I hit Control Enter, that does the same thing. It sends those down to the console. Oh, if you guys do you only have 3 panes up on the new RStudio? Yeah, so if you only have 3 panes, that means you haven't started a script yet. And I always forget that that's the default. So if you want to get a new script going, go File, New File, and RScript. And then that's going to, so let's go back. Let me get rid of this stuff. So your RStudio probably looks like this with just the 3 panes. Yeah. So you have, to get that other pane up, what you want to do is, let's go File, New File, and if I can get my mouse to work, RScript, and then that will open up that pane. So for today, I think that's enough. As long as you know that we've got the script up here and we type functions in up there, and then I'm going to hit Control Enter, and that sends my line, or I'm going to hit the Run button, and that'll send my line down to the console. That should be good enough for us to get going. One other thing that's probably a good idea to talk about are our studio projects. And so all an RStudio project is a folder, but it's a folder with some special stuff in it for RStudio, and it lets RStudio know that that it's a project, and you have some settings in there. But then it also makes managing our workspaces a little bit easier. So for today, let's go ahead and create a new RStudio project. And you can do that a couple of different ways. You can either go over to the this drop-down menu over here, or you can go File, New Project, and you'll get this window that pops open. And so we're going to go ahead and do it with a new directory. We can, at a later date, we can talk about these other options. But so we're going to go to New Directory, and we'll say Empty Project. And then it's going to put your project somewhere. If you have a place on your machine where you like to keep your projects, then you can click the Browse and then select where you want that to go. Mine's already set so I have a single folder on my machine where all my projects go. And so this one I'll call Basic Stats. I already have it in here, I think. Or do I not? I don't know. This one's good. Okay. So I created a new project, and I call that new project Basic Stats. And then you can see it did a few things. One, you notice it got rid of my source window because it's moved me into a new project. And now I've got this basic stats.rproj right here. You can see it lists my path where that thing got saved. And then also up here in the console, you can see where the console currently thinks it is, and it's in the same place right now, which is good. Which is kind of that's one of the reasons we want to use RStudio projects, is it helps maintain those working directories. And so to get started, let's go ahead and do File, New File, RScript, and then let's save this. Let's go File, Save As. And it's going to put it in that project that we just created, and we'll say basic stats.r. So we're going to save this as an R script. So all the R code we put is going to go into the script, and we'll save it for later. So I'll give everybody a little bit of time to get caught up, and if you're having problems, just raise your hand, and I can come around and help. And so essentially what we want to have is a RStudio project set up with the basic stats.r file that currently has nothing in it but saved. I should give up my stickies so people can, so I know when they're done. But you guys we're up to this point, everybody? Perfect. All right. Okay. So that's the basics of RStudio. I'm not going to get into any more details on it today. But we'll be using RStudio for all the classes, and so it'll become more and more familiar as we use it some more. All right. So the next thing that we want to do is let's jump in and take a look at the materials. So the materials are. I'll write this on the board bigger so you can see it. So the materials are going to be at https github.com/Brody Rstats/ basic stats. So just go to a browser, put that URL in, and you should get something that looks like this. And then to get to the materials, just scroll down, because I have the materials currently saved in the README file, and GitHub repositories look for that README file for the front page, so that's why I named it that. But down here now you'll see we've got the materials that we're going to go over today. So the way I set this up, we're going to be doing a little bit more than just basic stats. And a full disclosure and disclaimer before we get going. This is sort of like the I'm not a lawyer, so don't take this as legal advice. I am not a statistician, so don't take anything I say as statistical advice. Speak to your local friendly neighborhood statistician if you have real stats questions. But so with that out of the way, what we're going to be doing today is I kind of wanted to model sort of a typical beginning analysis project where you have to get data, or you have data that you've entered into a spreadsheet or a CSV file. And so you want to get that data, got to read it into R, maybe want to do some monkeying around with the data once it's in R to get it cleaned up. And then we'll go through and do some basic analysis. So we'll be doing really basic stats today. How do you calculate your basic statistics, mean, median, max, mean, standard deviation, those kinds of things. We'll do some sort of frequency stuff, how to get sort of counts on things. We'll talk a little bit about t-tests and ANOVA, and then some real basic linear modeling and correlations. And then we'll also, while it's not statistics per se, some basic data visualization is definitely sort of part of that first step of an analysis project when you're kind of starting to look at your data. So we'll show some basic data viz stuff too. All right, so everybody at this website been able to get there? So github.com/RodiRstats/basic_stats. Here, let me do this real quick. This URL right here. Yeah, I'll come around. You guys get there yet? Good, good, all right. Okay. So the first thing that we're going to do is work on getting some data. And so, and if you've done any of these things with me before, you're probably as sick of the NLA as I am. But so the NLA is a data set that was collected by EPA. It's an environmental monitoring data set. It's this one is from 2007. It's the National Lakes Assessment. And so they went around to 1,100 or so lakes across the U.S. and collected a whole suite of measurements from those. And the data is publicly available. So we're going to work with this data primarily because I'm really familiar with it. So if you run into problems as you're working on it, it at least won't be. I know the data well enough to be able to help work through problems easier than if we were using a brand new data set. So what we're going to do, and what you can do is sort of do some copy and pasting. And so let's go ahead and copy this top section, and then we can talk about each of the lines as we go through it. And let's copy that, and then go back to RStudio, and let's paste that into our script our empty script that we created. So you should have something that looks kind of like this. So here's some more of the sort of beginning basic stuff that looks like, oh, that's really small up there, isn't it? Let me go. Appearance, let's go. Let's bump that up to 14. Is that a little better or bigger? Good. All right. You know what? I'm not going to really show much of this stuff over here. All right, so what we've got here is this first line. What I'm doing with this is this little symbol right here, the less than and the hyphen. This is known as the assignment operator in R. And so essentially what this is telling R to do is take the stuff that's over here and assign it to an object named this. And so when I run that, I'll go ahead and run it. Set it down here, and then we can look over here in the environment tab. And now it has this little thing that it's saved over here. There's something in there called NLA_WQ_URL, and it's storing that actual URL. And so you remember that ls function that I showed earlier, and it came back, it said character 0, and it said that because there was no objects in memory. Now when I hit ls, it's going to say the NLA_WQ_URL. And so essentially all I've done is created a little placeholder for R to remember this URL. And the only reason I'm doing that is because it makes the code later a bit cleaner. Instead of having that big, long text string popping up later, we can just access this URL. So let's go ahead and run that one. We'll run the next one. This next one's doing the exact same thing. So remember, take all this stuff, all this text right here, that's the URL, and assign it to an object called this. So you can think of the assignment operator as an arrow. It's actually take this stuff and send it over here. You can do the assignment operator the other way, but don't do that. That's not good practice. All right, so now all we've done so far is have two objects that are storing the URL for our data sets. If we can look at these URLs, so EPA.gov, sites, production files, and finally it's pointing to a CSV file that's sitting on EPA servers.
Can you come again? How did you do
So how I took these?
that? Yes.
So I knew this URL. So what I did was I found the URL online, did a search for NLA data, and then found that URL and copied that and added it in. Anything that's a file path or a URL in R needs to be as character, so it needs to have the quotes around it. That's what R then knows that's a character or a string data type. And then it's using this assignment operator and assigning it to this. And so the way I ran it, I just did Control-Enter to send those down to the console. Or if you wanted to, you could use the run button like this. I'm just doing it over and over again, so it's just overwriting it. And so now if I go down here and type the name of that object, NLA_WQ URL, then it spits back. It knows that has that character string in it. So I'm just using this as a way to have the code be a little bit cleaner. These next two lines, this is sort of our first real function if this is your first time looking at R. So the read CSV function is a function that will take a CSV file. So everybody knows what I mean when I say CSV file. So CSV file is a comma separated file. So let's actually go and take a look at this on the web. So when I go and look at, I just entered I entered in that URL into my browser, and so here's a CSV file. So it's got some value, and then a comma, then another value, then a comma, then another value. So this is essentially, once we read this in and take a look at it, this is same thing as the spreadsheet. So you can save spreadsheets to CSV. I shouldn't say it's the same thing as a spreadsheet. Spreadsheets have other things that they do that aren't necessarily preferable. So what this is it's just a way to store data. And so you have rows and you have columns, and you're storing data in rows and columns. And it's a fairly universal data file that most stats programs will read in. All right. So what we're going to do now is read this stuff in. And so I'm going to say read CSV. And so the first thing that read CSV needs is the name of a file to read in. And so in this case, our file happens to be just sitting on the web. It could be a file that's sitting locally that you read in that way, or you could just do it this way. And then don't worry about this right now. We'll talk a little bit more about that later. You can run it without that and it'll work just fine. But so, oh yeah, and I got so functions in R. So the basic setup of a function is you're gonna have the function name, in this case read CSV, and then it's gonna have those parentheses. And so inside the parentheses are where the function's arguments go. So all functions will have some set of arguments. Some functions will work without arguments, like the ls function. When you typed in ls without anything in it, it just listed all my objects. And so some will do that, but they all will have some minimal set of arguments that are required. And so in the case of read CSV, you got to tell it what CSV you want to read in. So let me go ahead and run these, and I'll show you what happens. You run those, doesn't look like anything happens, but if we go over here and look at our environment tab again, you now see we have another section. Oops. We have another section over here that lists. So remember the assignment operator. I took read CSV, and then I'm assigning that to NLA_WQ. Read CSV, assigning that to NLA_SECI. And since we're not, this is not a all ecology environment group, SECI is SECI disk. It's a way to measure water clarity. And so it's a, I should bring one with me. It's a disk about the size of a Frisbee, and it's got 4 quadrants on it. 2 are black and 2 are white. And you attach it to a rope, and you drop the rope down in the water, and you take a look and say, until you can't see it anymore, and then you mark that depth, and that's your SECI depth. And so the clearer the water, the further down the thing can go. And so it's actually a fairly inexpensive way to get information on water clarity, and SECI is related to lots of things. And so it's available for almost all data sets. So that's SECI. Yep. Okay, let me take a look.
So we have to run these first. So what it's saying is NLA SECI URL not found. So it wasn't able to find this. If we come back up here. So it was saying it couldn't find, so you were telling it to use this, and it couldn't find that because you hadn't run those commands. So what I did there was I had my cursor. I hit Control Return. That's how I run the lines. The other way you can do it is with the Run button, and then that will send that down. So essentially, this is just text up here, and so we're just typing the text into and the reason we're doing that is we can save this and then rerun it later. And then so you just type the text in here, then you have to send the text down to R for R to actually do something with it. Okay. Yeah, so since these are on, oh, there it is, right quick.
You should be good now, because I don't think we're taking anything else off the other than some packages.
And what are you again?
What was that? Oh. All right. So I think everybody's,
I see. So line 6, you might want to explain that that's just.
Oh, yes. So yeah, so what we've got going on here is any line that begins with the hashtag or the pound symbol, that R is not going to read anything that comes after that. No, that's okay. So anytime those are used for comments. So anytime we're in our script, so URL for 2007 NLA water quality data. This is just information that I'm writing in the script for somebody else that we're going to give the script to. There's information in there that's not just code. So the person that's most likely going to read these comments is going to be you in like 6 months. So use comments liberally. You can't. You probably could use too many comments, but I've never seen that happen. So the more you write here, the easier it's going to be for you to. Right now, the code's pretty simple and straightforward. But as your code gets more and more complex, the comments are going to help you when you go back to that code later. All right. So now we should be at the point where we've got our 2 data frames, NLA SECI, NLA water quality, and we can start doing some stuff with them. All right, so let's go back to here. Oh, so we'll have you guys do a couple little challenges here. Number 1 is to make sure we have NLA water quality and NLA SECI read in. And so we will know that we have it read in. You can look over here in the environment in our studio and they'll be listed. Or you can do that ls function and you'll see them listed down here. Let me hide that. NLAWQ and NLA SECI. So that's the first thing. I want to make sure everybody's got that because everything we do from here on out is going to rely on those 2 data frames. And then let's see if we can figure out how many rows are in NLAWQ, how many rows are in NLA SECI, and then using the names function, list out all the column names to your screen. So that information is on the screen right now, for at least for the number of rows. And then you want to use the names function. So we go names, and then something has to go in there. And so in this case, you want to put the name of the data frame, and then that's going to spit all the names that are in this data frame out to the screen. Anyone want to take a stab at does everybody have the data frame pulled in? The 2 data frames pulled in? So data frames. The data frames, you're going to see a data frame over here. So remember we talked about the CSV is a comma separated file. And so when that gets pulled in, it gets pulled into something in R, which is known as a data frame. And so data frame is kind of the de facto structure for holding data in R. And so think of a spreadsheet. And those data frames are going to be listed in our studio over here. So you got NLA SECI, NLA water quality. How many rows are in each of these data frames? 1,252. Yeah. So this is going to list the number of observations and the number of variables. And so essentially observations in our data frame is going to be a row, and the variable is the columns is going to be a variable. And so if we want to look at this data frame, they've got we can do that pretty easily in our studio. We got the little button over here that allows us to view it. If you click on that, you'll get another window that opens up here. And we've got, if we scroll all the way to the bottom, 1,252. And then we've got our 9 variables at the top. And so for each line, so we've got site ID, the year it was sampled, the visit number, some lakes were visited more than once, whether or not SECI was sampled, or if they had, like, so here's an issue with some SECI readings. So you have 2 lakes. One lake is 3 meters deep, the other lake is 5 meters deep, and they're both crystal clear. And so you have one that's reading 3 and one that's reading 5, but you can't necessarily say one was more or less clear than the other because you're able to get all the way to the bottom in both. And so that's one thing that you often see with, you'll see some indication in data sets that have SECI that have some indication that you hit the bottom. Sec mean, this is the actual SECI value that we wanted. And then there's a couple other things on here as well. And so pretty much everything we do, our goal is to get stuff in and out of data frames in R. And so that's data frame will be what we work with. It makes sense for a lot of people who've done work with spreadsheets because it's the same kind of thing where you have rows as observations and columns as some measurement or some variable that was measured at each of those observations. All right, so let's take a look at what else did we have on here. Anybody try the names? Get the names for these data frames out? You get that to work? Yep. So when we do that, we can, let's go NLA WQ. So you'll notice that I'm kind of bumping back and forth between the console and the script. The script is, again, stuff that you need to think about. That's functions that you type in that you want to save and potentially run later. There's other things that you're going to want R to do that's going to be sort of interactive and maybe just a one-off kind of thing, or I don't need to save that in my script because I need information to put things into my script. And so I do names at the console all the time to see what the names of my different columns are, mainly because I want to include those names in a function up in my script. But so when I hit names and the name of the data frame, what this is doing is, you can see these up here. Actually, I've got SECI up there. Let's look at that one. So they match. Nope, that's water quality. So here's NLA water quality. You can see site ID, visit number. Names is just the way to do that in the console, and you spit back all the names of that names of the row or the columns in your data frame. All right. Were you able to get caught up? Good. All right, so the next thing we're going to do is do a little data cleaning here. One thing you will need to do if this is your first time. So I apologize, but a lot of this material were written assuming we had a little bit of some of the basics under our belt already. So we'll kind of work with this here. So the first, if you haven't, if this is your first time using R, you won't have dplyr installed already. And so the thing that you're going to need to do is do this install.packages. Oh, and the other thing you'll notice when I start typing, RStudio will give me some help. It'll pop up this thing, and so you're going to hit tab, and that will finish it off. So I want the install.packages, and the name of the package I'm going to install is dplyr, DPLYR. So what's happening here is there's something called CRAN, which is when you installed R, you got R from CRAN. So CRAN stands for the Comprehensive R Archive Network. And so one of the great things about R is that it's easily extensible through something called a package. And so somebody somewhere works on the package that does something, and they say, oh, this is great, I think other people might want to use this. They set all their code up in a specific way, it passes a certain number of checks, and they submit it off to CRAN, and then CRAN takes a look and says, yes, this is good, and then they put it into the archive, and then anybody else using install.packages can then go ahead and install that package. So dplyr is one of these packages, and so what dplyr is a package that helps us do is a lot of sort of data manipulation kind of stuff. And so it's a relatively new package. It was probably 2 or 3 years ago when it was initially released, and it has a bunch of cool things about it. But what we'll be using it for today is essentially filtering and selecting columns and that kind of stuff. So Before you use it though, you have to have it installed. So if you type install.packages, open paren, and then the name of the package in quotes. The quote stuff is gonna confuse you. Oh, and this is gonna take a long time because I'm on Linux and it has to build. If you're on Windows or Macs, the binaries probably have already been built, so the install should go quicker. So when you install packages, you only have to do it once per machine, and that's mostly true. If you update R, you need to install the package again, or if the package updates and you want to get the newer version, then you have to install the package again. But for the most part, as long as it's installed on your machine, you only have to do that once. The next step that we're going to do here, which we can go ahead and copy over while I finish installing, is let's go ahead and grab all of this stuff and we'll talk about it. All right, I'm going to go back to my script, and let's put this next set in. Including the library function in your script is always a good idea, because then when I share this script with somebody else, they'll know what packages I had to use to do that analysis. If I didn't include that in my script and then they see filter and select and they try to run those, it's not going to work because they're not using the filter and select from this package. So the second step of getting a package available for you to use is to use this library function. And so we install it once, and then every session we have to run library. So dplyr is then available. The code that we installed when it's doing all this stuff is available for my sessions when I type in library dplyr. And I shouldn't have installed this. I'm gonna remember not to install the other packages so I don't have to wait. It's done. All right. So let's go library, open paren, and the name dplyr, close paren. And there'll be some stuff that looks like this. It'll say attaching package dplyr. So essentially that's saying, okay, all the stuff from dplyr is now available for you to use. This is some additional information that's essentially saying, oh, there are functions in some other packages that have the same name as those in dplyr. The ones that you're going to be using are going to be the ones that come from dplyr, and then these other from stats and from base aren't going to be available immediately for your use. For what we're doing today, that's not going to be an issue. All right. So this next set, what we're doing with this next set is, so first of all, there's another little bit of syntax that I'm throwing at you here, and this is the pipe. So where you have the % sign, the greater than sign, and then another % sign. And so essentially what this is, if you used Linux before, the pipe essentially says, okay, take the results of this function and send it to the input into this next function. And so that's what this is doing. So it's taking whatever's on the left of it and sending it to the first argument of the function that comes next in the line. And so in this case, remember, and what's NLAWQ? Yeah, it's the data frame that we read in. So what it's doing, it's going to take this data frame and send it to the first argument of the filter function. And so the filter function, first argument of almost all dplyr functions is going to be a data frame. So if we have I start with my data frame, I use the pipe, I'm going to send it to the first argument with there. Then I don't have to specify the first argument for this argument. All I have to do is specify the stuff that I'm filtering. So in this case, I want to grab visit num equals 1. So I only want the lakes where we only had that first visit. I don't want to get multiple visits per lake. And then I also want to grab the prob lakes. And so this is a NLA thing. It's a probabilistic sample. And so there's some other different types of lakes that were sampled as part of the 2007 NLA, and so we want just the prob lakes. And so that's what this is saying. Saying, give me visit num equals 1, and then give me site type. Oops, don't do that. Give me site type equals prob lake. And so then you also notice the double equals here. So double equals, this is true across most programming languages. Double equals is equality. So if I'm going to go 1 equals 1, that returns true. 1 equals 1 is going to likely return an error because the equal sign also can be used as the assignment operator. And so any sort of logical or equating two things, it's always going to be the double equals. And so in this case, I want to get my visit numbers that are equal to 1 and my site types that are equal to prob lake. Then I'm going to take the result of that, which is a data frame. This works really nicely with dplyr. The pipes and dplyr they weren't necessarily developed together, but they were there was a lot of discussion back and forth between the developers of these things. And so dplyr, the way it works is that the first argument for most of the dplyr functions is a data frame, and the output of most of the functions from dplyr is a data frame. And so that works nicely within this this analysis pipeline where I start with a data frame, I'm going to pass it to this. This is going to return a data frame. I'm going to pass that data frame to my select. And so what I'm selecting out from this is just a subset of my columns. Because remember when we did this, names, NLA, WQ, we got all of these things that spit back to us. So I have 49, there's 51 different variables on this, and I want a smaller data set to work with. And so that's what I'm doing down here, is selecting out just those column names. So when I run this, depending on the version of RStudio you have, newer versions of RStudio, you notice how I was at the top of this line, and when I hit run, I'll do it again, it ran the whole pipeline. Earlier versions of RStudio are only going to run one line at a time, so you have to go through and hit run multiple times. So depending on if you've installed RStudio within the last week, you should be fine. And so now let's go ahead and let's see what happens. So you can look over here. So see, now I have a new data frame listed over here. That's NLA WQ CLN. And you'll notice I have fewer observations. I now have 1,033 observations. And then I also have, coincidentally, I selected 9 variables, and there's also 9 variables. So that could be a little confusing, but I selected, it was originally 51 variables, and I went down to 9 variables. And so that's what that 2-step process did, where I filtered and selected. Anybody here done any SQL or relational database stuff? Yeah, so this looks a lot like relational database stuff, especially the select. So the select statement is your first statement in almost any SQL call, and what it does is select out columns. And so that's not an accident in here. All right, so we're gonna do the same thing on the
Sorry, I got every step worked except this selection. What function for me? That's online thinking.
Right. You didn't run. Yeah, so essentially what it was saying is, okay, that function comes from dplyr,
Right.
and you didn't tell R to look for that package.
Thank you.
Yep.
run each of these lines. So the first one's going to add that, first one added each line, and then we'll run, let's see, we're going to run all of those. And so, and we can see it created this new one, and now we'll run this one. Created that one. And then the joint stuff, yeah. And so when we're typing these things, you got to make sure that each of those lines get sent and run by R. So typing it in up here R doesn't do anything with it. You have to send it down to the console, make sure R then runs that function. Yeah, it looks like you got it installed just fine. So starting at line 11, yeah. Start and run those down. You should be able. That should work. All right.
So where were we? All right. So the next one. This is just cleaning up the SECI data sets. We're kind of doing the similar thing. We're going to grab the visit num equals 1. There is no site type in the SECI table, and so we can't select on that. But then we are just going to select out just the site ID and the value, the variable that we want, which is called sec mean. They took multiple measurements, hence sec mean. So we run those, and so now you can see over here I've got NLA SECI clean, NLA water quality, CLN. And so you can see indeed up here, I filtered out some variables. I've got fewer, the 2 columns, just the 2 columns that I selected. And so now finally, since I've got 2 separate tables, what I want to do is pull those 2 together. And so this is doing a join. When I say join 2 tables together, does that mean, does that not mean something to people? So when you join 2 tables together, again, this is borrowed from relational databases. You got table 1 and table 2, and if I want to merge those 2 together, if I have a column that's common between those 2 tables, then I can merge them together. So in this case, we've got site ID in both of these, and so it's the same site ID. So there's a lake 1, lake 2, lake 3, where I've got measurements for it over here, and then my other table, lake 1, lake 2, lake 3, I've got my SECI measurements over here. Then I can join those 2 tables together based on that common ID, and it will pull. And so in this case, what I want to pull is my sec mean into my table. So this, we can say, we look at NLA W, let's look at the names on this. Names, NLA WQ clean. So I got site ID, I got state, EPA region, some other stuff. And then if I look at I've got site ID and sec mean. So now I can join these 2 based on site ID, and the result should have it should look very similar to this one, except for it's going to have 1 more column on the end. It's going to have sec mean on the end. And the way we do that, again with dplyr, is using left join. And I'll show you what I did here in just a sec. So left join, there's a bunch of different types of join. There's a left join, there's a right join. There's inner joins, there's full joins, there's anti-joins. They all do different things. Left join, what it will do is it'll keep all the observations from the table on the left. And so in this case, you can think of this is the table, and the first table that you list is your left table. So it's going to keep all my rows, and then it's going to bring in just the matching rows from NLA SECI. And so you can imagine I could have a set of site IDs over here and a set of site IDs over here, but they may be slightly different. I may not have all of the site IDs in one table, may not be represented in the other table. And so that's the different types of joins. If that's something that you find yourself having to do, we can chat and figure out what's the best way to do those kind of joins. And then this next little thing I threw in here, there is missing data in in some of these columns, and so the complete cases function. You can see I'm nesting my functions here, and so the internal function is the one that gets interpreted first, and so. I don't want to get in the details of what this is doing right now, but so essentially what it, or how it's working, I'll tell you what it's doing. What it's doing is it's looking across NTL, which is total nitrogen, PTL, total phosphorus, turb is turbidity, CHLA is chlorophyll A, and then sec-mean is the Secchi depth. It's looking across all of those, and if any one of those has missing data in it, it's going to throw out that row of data. This is one way you can deal with missing data. This is a little heavy-handed way to do it, but for the purposes of this class, it's okay. Because I mean, you can imagine I have this data set. Maybe I don't want to use turbidity in some analysis, and if I've done this first and thrown out a row of data, I may have perfectly good data that could be used, but I threw it out. But for this, don't again. I go back to my disclaimer on statistical advice. This is not necessarily how I would do the my analysis straight up by throwing out all my complete cases. That determination would come later as to how to deal with NAs in a particular step. But this gives us a nice clean data set where you don't have to worry about NA values anymore. And all this Tibblediff function is doing is it provides a nice way to print my data frame. So if I were just to look at NLA on its own, it does that. It spits out a whole bunch of stuff to the screen. And so it's difficult for me to, because it reaches a sort of maximum to what it can print. It tries to print all my columns. Tibblediff is smart. I'm still amazed by it. Here, I'll show you. So when I do this, and then it gives me, it returns the first 10 rows. It says it's a tibble with 974 rows and 10 columns. And then it says, oh, I did 10. There's 964 more rows, and then 5 more variables that it didn't show. And it determines what variables it can show on the screen based on the width of your console window, which it's still just, I'm like, wow, that's cool. We do this, and now it actually shows the whole thing. So we've got first row in the data set. That's my my first observation. Here's its site ID that was measured in Montana, which is EPA Region 8. This was actually a reference lake, or classified as a reference quality lake. It's a natural lake. It has very low phosphorus, relatively low nitrogen. It's almost 6.5 meters in the Secchi depth, so that's a nice, clean, clear lake. Hence it being reference lake. All right. So
The second, right under the column headings, is that telling you it's treating it as a care?
yeah. So what this is doing, this is telling the data type for that column, and so you'll notice there are no, if you've used R before, there are no factors here. That strings as factors thing that we did with the read CSV, default is to turn those into factors, and we're not going to talk about factors really in here today. So the default is best to have it as characters, and then if we want to use factors are a way for that R can deal with categorical data. So low, medium, high, that would be a classic categorical data. Gender would be a categorical data. Yeah, so those kind of things. Some of these probably should be turned into factors, but I want to determine how that factor gets generated. I don't want R to do it automatically for me, which is what the read CSV defaults do. So yeah, so this one's character, integer, double. So these are numeric. So that's another nice thing with the Tibblediff is it gives all that information for you right there up front. Before that was around, the other way you could have done that would be with str. That gives you some information. The Tibble format's better. It's more of a what you'd expect, how you'd expect to see that information. All right. So let's try using filter and select. This next step to create a new data frame that has just nitrogen and phosphorus and is only for the state of Rhode Island. So look at, what you'd want to do is you can start with the NLA data frame that you have, and you want to do a filter step and a select step. So it's going to look pretty similar to this, but we'll have a different input data frame, and we'll be filtering out on something different. We'll be selecting something different. And so if you don't have the NLA data frame, raise your hand. I can come around and make sure everybody's at least up to having the NLA data frame. And then if you have that, then you can start working on the filtering out phosphorus and nitrogen. Is that what I said? Yeah, phosphorus and nitrogen for the state of Rhode Island. And you can work with people next to you if you want to. It's if you're running into problems, you can ask the people next to you.
So it's an NLA not found. So this.
Yeah.
I'm gonna.
Yeah.
I guess I can try
I
to
think
vote.
you have to do filter first. Yeah. What are we?
All right, so let me see you try to run
Because when I
that.
did it that way, when I did it the other way around, it didn't work because I didn't select state, which is what you
So essentially, it's only going to run the lines that
Filter
are
by
currently
state first.
so it's not running the lines above it.
Because otherwise you have to
So
select
if you want to,
the
there's
state
a
as
couple
well
ways
as
you can do
everything
that. You can
else.
either
and then
start at this line.
I see. So
Okay,
it's
so
just
that's
a
why
little
it
bit
makes sense.
more efficient.
So
So
you can start it until you hit run, it will automatically go to the next line. And then as we step through this, you gotta, if you start in the bottom, it's not gonna run the stuff that's up above it. It's only gonna run the first line. So you either start at the line and work all the way through, or you can select, and then it will send all those at once. I usually, the way I normally do it, so I'm on the line, and I'll do my control. Just gotta make sure you start up and then work all the way down.
Oh, yeah, because I think you need either the whole thing or, yeah.
Oh, I don't want to join.
Well, you do, but you want, yeah, you want to work out under what you already know. There's other.
Oh, so I run this again. Okay.
You don't have the
I guess I
section,
should
you
have
have
kept.
the
The
section.
second thing what I
So
have
go
said,
up to
yeah.
So the reason you tell that because I'm over here. And so I should have done that section. So you start at line 8, yeah, go ahead and run that.
Yeah, so do the full left, right?
No, I mean, you could just use you can just create a new data frame, just call it whatever. So we basically so this is a data frame side that we just created from putting these two together, and so you can just make a new one, you can call it like NLA2.
Okay.
So that's just a variable you're using to store all of this information.
Now you have that. Now you should be able to start.
Okay, so what should I be
run
adding
each
to
of the
this?
lines going down.
Cluster versus cluster? Not doing enough by itself.
I think it's,
You all set?
Yeah.
so the thing is that you just need to make, we already using this thing, we're using that, because we already have it, so it's just, so you just want to make a new one, this is what I did.
Get these. So the,
Yeah, so I was.
So yeah, so I just like cleaned everything, right? The T and I just called it.
Looks like you forgot to load up the library.
Yeah, no, it's not.
yeah, so essentially when you see that, it says that it doesn't.
That's that big thing you don't get. It has to have.
Well, in this case, it, gave you the unexpected symbol because it doesn't know what the type is, because they just load it up when you load up. So when you hear, when you see stuff like that, or if you see something like that, or you
Then yeah,
know
you
the
just
select
call it
function,
something different.
then you go, oh wait, no, I think I forgot to load up my.
You can call it
library. So remember, you install the package once, and then the library's loaded now. You don't have to do it again unless you shut down our studio. Next time you open our studio, you'll have to run that again. Again, that's why we keep that saved in that script. Then we just go back to the script and run those lines again, and you go back to the point that you had left off. Okay.
Yeah, you want to change this, like, analyze
That piece changed to.
just analyze. So that's the analyze.
All right.
Oh, and you just need quotes now.
You get it? Yeah. I'm gonna get you shirts and hats, and you just walk around, be my billboard.
These dirt flights.
Oh, right, okay.
Oh, gee. Actually, they do look like dart flights. That's what they look like. I could actually. Did you have a question?
Yes. So, Rhode Island, or RI, is a character.
Yeah.
But column titles don't count.
No, because the column titles. Because remember, the first argument for the dplyr is the name of the data frame, and so because you specified the name of the data frame, it knows that those are column. If you put quotes around it, then it's gonna just do quotes of sec mean equals something, and so it wouldn't be that. It's by, you don't have to specify because you've already specified the name of the data frame that's pulling that column from. That was a really awful explanation of that, but good.
That's like the biggest problem I have right now is I forget what these quotes have.
So
I just try and put things until it works.
that's the best advice I could provide with regards to that. So quotes and not quotes is always something that trips people up, and so if it's character or a path name or a URL, it's always going to need quotes, and then usually if things are an object in memory, they don't need quotes because you're specifying that name of that object. And so this is kind of a case of that, because you've got within the environment of that data frame, you have an object called sec mean. And so, but then there's this unhandy thing about it's very handy for lots of things. It makes things a little bit easier to use. Sometimes it's called non-standard evaluation. And so some things will work different ways, or will work ways that you don't expect them to. And so I don't know if this is a true example of non-standard evaluation, but the library function, we did this without quotes and it worked just fine. Based on the idea that it's accessing an object. That doesn't work because this isn't an object yet. We haven't attached anything. And so this, to be pedantic about it, this is how the library function should look. You should have it wrapped in quotes, but it works both ways. And so quotes can be tricky. And so again, that's the best advice is think about it, try it the way that you think it works, and then if it doesn't work that way, then try it the other way. So it's a very unsatisfying answer, but it's the best one I have. All right, so what did we want to do? Yeah, that sounds about right. Let's try this one. Okay, so the RI challenge, Rhode Island challenge. All right, so The way I would have done this would have been filter state equals RI and select NTL and PTL. Probably should have done this too. Site ID. And then we can run that. Oh. Aha. Anyone see the error that I made? Yeah.
That's actually an error message that makes sense though.
You know why? That's an error message that makes sense because it's an error message written by Hadley for the filter function. So Hadley, we haven't talked about Hadley. We will, from here on out in our future Rhody Rstats meeting, we will start off with a blessing to Hadley because of everything he does makes our lives easier. Some people disagree because it's new stuff and it's like, oh, he's changing R, and he's changing R for the better if he is changing it. Because a lot of the packages that he writes do things that R can do already, but does them slightly easier, and so they're great. His packages are fantastic, and so you can see this. Filter takes unnamed arguments, so that doesn't make much sense. But this here, wait, don't you mean equals equals? It is very helpful. So now when we run this, we get, I didn't save it out to an object. By doing this without, because I don't have that assignment operator, by doing this without the assignment operator, it's just going to run it and spit it out to the screen. If I wanted to save this, I could have done something like this, NLA, and then run that. And then if I look at RI, NLA, run that, and then it spits it out. So these are the 10 lakes that were sampled in 2007 in Rhode Island. So I mean, you can see the NLA is a great data set for national stuff, probably not a great data set for state level stuff, depending on the size of the state because it's area weighted. So larger states got slightly more lakes than smaller states. Such is Rhode Island's fate. All right. Does this make sense at the filter and select? Great. All right, now we're actually going to do stats. But this is pretty typical of an analysis process of most of your time is going to be spent, and we didn't spend that much time, messing around with your data, getting your data into a format that lets you do the analysis, especially with like text stuff. That's going to be like 99% of your time, and then the analysis will be very unsatisfying. Done. Well, it'll be satisfying because it'll be cool stuff, but all of the effort's going to be on cleaning things up. All right. So now we have a data frame. Everybody should know have a decent idea what a data frame is, and now we can start looking at that data frame and doing some analysis. So let's do some basic stats. So the first function I'll show you is summary. Oops. Question? Okay. So the summary function is actually there's several of these sort of default functions that R has. Summary is one of them. Plot's another one. There's a lot more, and I'm blanking on them right now. But so they'll work differently depending on the type of object that you send to that function. So when you pass a data frame to summary, what it's going to do is it's going to list each of your columns and provide some basic summary information about that column. And so if they're character, pretty much all it's going to do is tell you that it's character and how long it is. But if it's integer or numeric, it's going to return some stats for that for you. It's going to give you your min, your median, your max, your mean, and your first and third quartiles. And so you can, with one function, you can look at an entire data frame and get information on kind of the basics of the distribution of that column. So we can see We've got a minimum of 1 for phosphorus and a maximum of 4,679. So we're really covering the stretch here on different phosphorus loads and lakes. Sec mean, we have some SECI that were actually 0.04 meters. That's probably one of those dirty cow ponds in Iowa somewhere that they couldn't see anything. Up to a maximum of, I just want to know that they had a rope that long. 36 meters was the like Lake Tahoe. Well, Tahoe's been having problems lately, so maybe not anymore. But so yeah, that's a deep, clear lake. So summary is useful in that it provides all this information for your whole data frame sort of all at once. Let's see, what else did we have in here? Oh, then we can also access these things individually. We can do, there's the mean function, and I'm going to send that down. So this is for, if you haven't, if this is your first time with R, you haven't seen this before. So what this is a way to access those individual columns. So essentially what I'm doing is you give it the name of the data frame, in this case NLA, and then the $sign, and then the $sign is indicating that I'm accessing this column called NTL. So I want to, in this case, it's giving me the mean of the mean nitrogen for all the lakes in the NLA. So this is data frame, NLA, because that's the one that we created. And then this is the name of a column that I want to access. In this case, the name is NTL. And this is where I use that names function all the time. It's like, oh, what was the name of this column? And then you can type names. Oh, it was, turb. So if I wanted to look at my mean or my turbidity, mean is going to be NLA $sign. And you'll also see what RStudio will do. It knows the column names because this is in memory. And then, oh, look, I can scroll down here. Let's get to turbidity. And then I can control enter, run that. And then the mean turbidity was 14. I can't remember the NTUs. And there's other ones. We can do min, NLA $sign NTL. Do max, NLA $sign NTL. We can do median. We can do standard deviation. What else? Min, max, standard, oh yeah. The IQR, anyone know what the IQR is? Yeah, the interquartile range. So the interquartile range, so it's going to take your quartiles, the first and third quartile, and give you the range between those two. And then the range is just going to actually return two values. It's going to return the min and the max. So these are some easy ways to get those basic stats for your different columns in your data frame. Quick, we talked a little bit about no data values, but we're not dealing with them because we dealt with, remember, that complete cases thing that we did in the filter. I was, again, heavy-handed and saying I don't want to deal with any NAs right now. But if we had something that had, I'm going to go and copy it over so it matches what's in the. So again, some more basic R stuff. So I'm creating an object. Here's my assignment. I know I'm creating an object because I have this assignment operator. In the C function, this is a way to create a vector from scratch. So each of our columns in a data frame is a vector. And so it's a vector, essentially any list of values that we're storing as an object. And so in this case, it's a numeric vector, and I've put in an NA value. So NA is R's official way of dealing with no data values. And so when I run this, you can now see I've got this X over here in my environment. It's listing that. And I can print that back out to the screen. And so there's 37, 22, NA, 41, and 19. So for whatever reason, that third value, we weren't able to get a measurement for it, pretend. And if I take mean of X, any idea what, well, it says right up there, but the mean of a vector with an NA value is NA, because R is like, well, how do I take mean of missing data? So you explicitly have to tell R what to do with that value. On most of these functions that we just talked about, the mean, median, standard deviation, they have an argument on them called na.rm. And I'm going to set that equals to true. But you'll notice, again, this is a single equals here, because I'm not saying does na.rm equal true. I'm saying there's an argument that I'm assigning to the value of true. And so when the mean function sees that, it's going to say, okay, remove the NAs from the vector and then return the actual value. And so when I do that, I get 29.75 because it took these values, dropped the NA, and it gave me the mean of the remaining values. All right. Table. So let's talk a little bit about table. Tables is a handy way to get sort of some frequency and some count information on your vectors. So one of the things we did up here, let's do up here, counts and frequencies. We go table, NLA. This lake origin column in our data set is whether or not the lake was a natural lake or a man-made lake. And so what we can do with that, and so when I do a table of this, it's going to give me a count of how many were natural and how many were man-made, or how many of whatever values I have in this thing. And so when you run that, it returns back man-made. There were 568 lakes that were man-made in the 2007 NLA, and then 406 of those or in our filtered version of it, 406 of those were natural lakes. For a numeric, I'm afraid no, it'll either error. I'm not actually sure. Let's try it with, I know that's integer, so if it works with anything, it'll work with that. It'll do that. So it gives it to you, but it's essentially, well, guess what? There's probably, yeah, there's a few of these that have, like there were a couple 255s, but that's because this is integer. If we did it for something like chlorophyll A, which is numeric, they're probably all going to be, oh, there's a couple twos. Well, of course, 62. So yeah, it'll do it, but it's really not what you want. All right, so then another thing that's really handy with table, and I use it quite a bit for this, especially if you're doing any prediction. Say you've got like a logistic regression model, and so you spit out your predicted classes, your ones and zeros, and then you had your observed classes of ones and zeros, and you want to see sort of the accuracy of your predicted versus observed. Table is really handy for that. So let me grab these over. Good, how are you? So this just creating some dummy data here. We've got X and X and Y, so just some ones and zeros. So here's something that be sort of like that logistic regression example. And then when we run table, and I'll take a look at this, what it does is it spits back a confusion matrix or an error matrix of the places where those two vectors matched, how many were both zero, and then how many were both 1, and how many were misclassified. So in this case, okay, so 1 and 1, 1 and 1, 1 and 1, 1 and 1. So it should be 4. So I got 4 on my 1s and 1s. And the same goes for the 0s. And then we can look at, this is going to be 1 and 0. And that's 1 and 0, 1 and 0. We get our 3 count there. And so essentially, it's an error matrix. It's telling me the diagonals are the values that matched, that were both your x and your y had the same value, and then the off diagonals are the ones where there was a mismatch. And so this is a handy way of looking at that. There's prop.table, which will, instead of giving you the counts, will give you the proportions. You type in the right names, it'll give you the proportions of those. So we had a 66% total accuracy on this. You can get that by adding up what's on the diagonals. And so that's another useful one to know if you have that kind of data. And since we've already been talking about dplyr, we can do some fun stuff here. So often the mean so like the mean nitrogen for a lake in the United States is really a entirely uninteresting value, because there's lakes of different size, lakes of different sort of trophic state. There's all sorts of different things that can be going on with a different lake, that having one mean value for all lakes in the U.S. doesn't tell us anything. And so what we may want to do is look at mean values across some sort of grouping. So in this one, what we want to do is, so remember that lake origin where it was man-made or natural lakes. So it might be interesting. What's the average nitrogen for man-made lakes in the U.S.? Average nitrogen for natural lakes in the U.S. And so we can use the group by and the summarize function from dplyr to do this. So let me go ahead and run this and we can show it. And so what this does here, we've got the group by. You specify, here we go, NLA. I'm going to pipe that to the first argument of group by. Remember that the first argument of most dplyr functions is going to be a data frame. And then I want to create a group based on lake origin. And then for each of those groups, I want to calculate these summary stats. And so what I'm doing here, in the output, it's going to create a column called mean underscore NTL, median underscore NTL, and SD underscore NTL. And then this is the actual function that it's doing. It's going to take the mean of the NTL column. And so we get the result down here. And we have, for each of our different classes, man-made and natural. And then you get the man-made nitrogen is 842. Average is 842, and the natural is 1676. So that's perhaps not what you would have expected, but who knows what's going on with this. There may be one natural lake that's way out, throwing this average off. And yes, indeed, that is the case. With a standard deviation of 961 for the man-made lakes and a standard deviation of 3,000 for the natural lakes. And you can also see that with the medians are much closer than the means here. So this is a sort of a handy way to get those quick group stats based on something you think may have something to do with whatever stat you're looking at. All right, was there anything else in here? Oh yes, and then this just because it's cool. And we can talk about some of this stuff at later meetings. And so this is getting into using NIDAR. And so NIDAR is a package that lets you write in something called Markdown, and you can Markdown and other things. But you can write in Markdown, write your text, and then combine code. That's actually how I create this whole thing. Is This is written in an R Markdown file. I run it through knitr, and it spits out a clean Markdown file that then GitHub can read. And so if I run this, what it does is it takes that data frame and returns it in Markdown table format. And so this is Markdown table format, and GitHub is nice, and it actually renders that as an HTML table. And so we have this. I can't really see it up there, but there are different colorings. There's a gray on the second row, white on that first row, and so it has the striping in there, so it's a little bit easier to see. If you don't have, this may not work for you because if you don't have knitr installed on your machine, but you can always go install.packages knitr, and then that will install. And then a brief statement on this syntax here. What this syntax here with that double colon in there is saying is this is the package name, and then this is the function name. So I could have gone library knitr, then cable. Instead of doing the library call, I can do this where I specify it just in one line. So from the knitr package, grab the cable function and run it. And again, that was just because. And we can talk more about that, and kind of it's sort of getting into reproducible research and literate programming, where you have your text and your code and your data and your output all rolled into one document.
Is that what you would do too if you wanted to use something that we overwrote, like a function that was in?
Exactly. So filter. When we did library dplyr. Yeah. Let's see if I can. Oh, it's going to be way up here, isn't it? There it is. I found it. So up here. So when we, I kind of breezed through this. We did library dplyr. It said, hey, I'm attaching dplyr here, and the following objects are masked from package stats, filter and lag. We've used the filter function. When we used it, since we had library dplyr, we were using the dplyr filter function. But if I actually wanted to use the filter function after loading dplyr from the stats package, I could do, I'll type it up here so you can scroll the way down. You could do this. And then the 2 semicolons. So I'm specifying, being very explicit in the package that I want to use and in the function name. And so in this case, this is going to use the filter function from the stats package. You can always do this if you want. Always use the package name and the 2 semicolons. It's more explicit and in theory more clear than not doing it. That's what you're asking? Yeah. All right. Let's see. I think we've gotten up to a quick challenge here. So let's go ahead and spend some time with this. What's the standard deviation for phosphorus? What's the median Secchi depth for this data set? You can play around with some others. The second one is let's redo that dplyr, the dplyr trick where we're doing the grouping. The example I did was the man-made, natural, and nitrogen. Go ahead and do Secchi depth based on the RT-NLA. This is a reference class. There's 3 classes in it. There's reference, there's so-so, and unfortunately, there's trashed. Somehow the trashed reference classification made it through NLA review, through EPA review somehow. So, well, you can have some guesses and some hypotheses about what is going on there with regard to reference class. Maybe thinking that the reference lakes would have a greater Secchi depth than the trash lakes, and so we can look at the mean values and see if that falls out. And then this last one is we looked at with summary. We saw some of those quantiles. Those gave us the first and third quantile, but you may want something different. And so try the quantile function to return the 33rd and 66th quantiles for, did I say, for NTL. And if you're stuck on something, raise your hand and I can come around and give you a hand. And if you came in late and if you would like a sticker, please come up and grab a Rody Rstats sticker. There you go.
Okay. Like, boot camping. I did that last summer. And so I kind of wanted to go get it.
So the names, it's going to be one for the name data frame to return the names.
Right in the middle of one of the days.
NLA is the data. We can actually click on that. So one way to do that. That's the return.
Yeah, you can kind of
I
tell what
couldn't-
she's doing.
And then if you want to access the column NTL, that's where you get the dollar sign. So that's and we bring that up. That, and then when I hit that, it's actually it returns. That's the actual data that's stored in that thing. So that's why I can move on.
Yeah, that's what, I wrote my own stuff for the first time this, like a couple weeks ago.
So took all those values and calculated the mean of those. So yeah, that's
Kids.
data frame,
The problem
the
is
name
I
of the data
don't
frame,
understand
dollar sign,
the
and
stats
then
and understand the coding at the same
Does that
time.
make
So
sense?
it's kind of like a double challenge.
This is a lot for you guys, coming in without having had any art, sort of. But hey, it's sink or swim. So, wait, so. Close. So what this, that's the name of the data frame, and then the dollar sign, and the name of the column. So that's the PTL column from the, so this, and that, and we actually do that with it actually returns all the data from that column. Does that make sense? Yeah. Yeah. Yeah.
So anybody get the dplyr group by to work? Oh yeah.
So change this. So this works. Our family doesn't exist because we didn't create it. I added this one. So
Yeah,
So
No, oh, sorry, it's right here.
you were telling us, I want to print out RINLA, but before we had created it. So now created it, and then we assignment operator took all of this stuff and then assigned it to RINLA. I was telling this is a lot. for the project.
We're gonna be,
Well, depending on how many, especially
So everybody check in.
if you guys have questions, I'll, there's facility and resources online for this. So one that's I like artifacts stuff.
Made that was great.
Most days, some sort of working with students here. Other one is just.
So this one obviously is basically Rstats, which is good. It does a really good job. This doesn't use our studio. It's going straight from the article, but instead of using the window, you can just use. You can type all the stuff and it's down here. But so this one is a good, so it goes through some of the basics of math, and then it gets into assigning objects, talks a little bit about vectors, talks about data frames. So that's a good sort of first overview one. Yeah. Hey.
So,
I'm not sure.
speaking of computers,
Sure. Yeah, you can.
That might be the best way.
Yeah, you can. You've got my EPA. Yeah. Just ping me there, and I can.
Okay.
We can set something
So I
up.
think I'll give it a go.
Okay, that sounds good. Hey, no, that's not a problem. You got to teach.
Like, second, me,
So I assume you got the standard deviation and the median stuff figured out. I saw a couple of head nods when I asked earlier if you got the group by. Are you still working on the group by? Here, I'll do a. What did I say? I can't even remember. Mean Secchi by reference class. So if we wanted to save this out to an object, we could type something like ref Secchi, give it whatever name I want, and then I'm going to pass it the NLA data frame, and I'm going to do a group by. And what am I grouping on? RTNLA. And then I'm going to pipe that to my summarize, not summary. Because I'm so used to summary is a different function. I'm so used to writing summary. I put summary in here all the time and get angry when it doesn't work, and because I made a mistake. Summarize is the function that we want, and so we can give it a name if we want. We'll say, what did I say? Mean Secchi. And we're going to go mean of, should have done median. Mean is sec mean. And that should do it. There we go. So we get each of the different classes in here: the reference, the so-so, and the trash. And there is the reference lakes have the highest average Secchi depth. The so-so in the middle, and the trash having the worst. What was your hang up on that? For those that were having trouble with it.
Oh,
Put in the second bracket after this.
after the summarize.
Yeah, I did forget that.
Oh, forgetting which one?
When it says summarize means that you haven't put that loss.
Oh, you didn't. Oh, you didn't. You forgot the closing paren. Yeah, the closing stuff will, and if you forget that, it will. Yeah. Or in this case, it'll do this, where you notice how my prompt changed over here. It was the typical prompt, and then it changed to the plus sign. So essentially, when you see that R saying yes, it's waiting for you to give it more information, because essentially I hit a return when I didn't have my closing paren for my summarize. So if you see that, usually the best course of action is to hit escape, in realizing, okay, I messed something up, and then go into your text editor and figure it out. In this case, you could probably guess, oh, I need to have a closing paren, and you could type that, and it would work. Oh, yeah. So yeah, up in the that's another reason to use the text editor. If I don't do that, usually on save it'll do it. So now see this up here. I got this little red X, and it's saying it's somewhat helpful. Yeah, because that after expression unmatched opening bracket. That's the part there that's useful. But generally, if you see those, I don't really look at what it's trying to tell me. I see that and I assume, okay, I forgot a closing quote, I forgot a closing paren, I forgot a. You can also use square curly brackets and square brackets in R. And if I didn't have one of those, it will give me that same symbol. All right. So there's that. And then, did anyone try the quantile? Got it? So essentially what I was asking you to do is to start with this. Oop, not all of that. And change it. So instead of getting the 0th, the 0.5 and the 1 percentiles, you would get the 33rd and 66th. And so what we can do with that, what would I change here to get the 33rd and 66th? So yeah, what numbers would I put here? Yeah, it has to be. It's looking for a percentile, so between 0 and 1, or proportion. So we'd put 0. Well, not O. 0 point what? Let me get rid of. You don't. Well, no, the first 0 that'll return the min. You could leave that in there, but it would give you. You can do that. And then so that's the minimum value in the NTL. That's why. And so if you just want the 33rd and the 66th, you would do it like this. And run that, and then it gives you the 33rd and 66th percentile of NTL. All right. So that's the basic stats. Now let's jump in. So the rest, this one should, at least the basic ones should go pretty quickly, since the syntax is pretty much the same as to what we've seen already. So if we want to do a histogram, let's go is we can use the hist function, NLA $NTL, run that, and it returns my histogram. This is obviously not normally distributed. So one thing we might want to do is, I use log1p in the example. So essentially what log1p is doing, it's the natural log, but it's adding 1 to it. So if you have 0 values, it helps, you just do that add 1, and it will then you get the log of those instead of having an error thrown back at you. But now when I do this, it's a nice log normally distributed set of data. And then you can play with, and I can never remember the breaks. Say we want to do more. And then that will add smaller bins. So histogram, the breaks are figuring out how many bins to bin your data up in to calculate the frequencies. That's histogram. We can do, the density is a nice one. So if we go density log1p NLA $NTL. So if we just do that by itself, it's not going to, low 1p. There we go. It returns something back. So essentially, it's a density function that it returns back. But we would perhaps want to plot this. And so if I plot my density function, then it returns this. So this gives that nice sort of continuous density function as opposed to having the individual bars for the histogram. Just a different way to display essentially the same information. Your plots aren't showing up. Did you zoom out at one point? Yeah, because if you zoomed out, it'll always send them off to that window. Yeah, if you X out of that, then it will.
Now try running it.
It should. No. Well, it's for some reason it's wanting to open a. I don't know why that is.
They're existing.
Yeah.
They exist somewhere.
I think that's gotta get right now.
All right, let's see. What else can we do? We can do box plots. Let's do NLA, chlorophyll A this time. I'll go ahead and do, I know all of these are log normal. And so the box plot of one variable is I find always just somewhat humorous because it's not a terribly informative plot. But one of the nice thing about these is we can use the formula notation, and let's say RT NLA. Oops. Run that and I'll talk about it. So this, with the little squiggly line, the tilde, this is indicating a formula. And so typically formulas you'd read, so y equals x, or so let's think of a linear regression, y equals mx plus b. And so in a linear regression, your m and your b are going to get determined by the values. And so all we have to do is specify as the x. Our equal sign is used elsewhere for something in R, so we had to have a different character to identify the notation. And so the tilde, this whole thing is my formula call. And so this is y, so whatever's on the y, in this case the y in a box plot is going to be the actual values. Tilde x, whatever's on my x-axis is going to be my classes that it uses to break out and do a different box plot for each. So this, I do these fairly often to kind of look at the distribution of values across different classes. And so here we go. Again, we saw this more or less when we did that group by, but here's the sort of the visual representation of that. And then what else did we do? Box plots. I did by EPA region. Scatter plots. So the plot function, if you pass it to two vectors, and so in this case we're passing PTL and chlorophyll from the NLA data frame and log transforming it, and so this way we get our scatter plot of X versus Y. We can also do the pairs plot or a scatter plot matrix. Later. If you pass the plot a data frame to the plot function, what it will try to do is create a plot for each pairwise pairwise relationship in that data frame. Be careful with this. If you have a data frame that's got 10 columns in it, it's going to do a 10 by 10. That wouldn't be so bad. But if we tried to do, remember our original data frame had 51 columns in it, then it's going to try to return a 51 by 51 matrix, which it'll take a little bit of time and will be unintelligible because all your plots are going to be tiny little things. And so what I've done with this, I'm not going to get into indexing right now other than to show you that this is indexing. So what this is telling R to do is give me the 6th through 10th columns. So this is going to do 6, 7, 8, 9, and 10. And so it's going to return, it'll be a 5 by 5 scatter plot matrix. Let's go ahead and run that. Zoom out to make this bigger. And so now we can see each of the, it goes PTL, NTL. So this is going to be, these are all going to be phosphorus on the Y, and then phosphorus versus nitrogen, phosphorus versus turbidity, phosphorus versus chlorophyll, and phosphorus versus sec mean. So this, again, this is a really useful one to write when you're first starting to dig into a data set, is to do these scatter plot matrices, and then you can start looking to see some of the pairwise relationships that might be in there. And not surprising, there's with this data set, there's some nice relationships in there. That's the scatter plot matrix, and then I'll show you this one. But this is pretty typical with data viz. Is often the viz you want, the data set needs to be massaged before you can get that viz out. And so I'm going to run this one real quickly. Put it over here. Oh, I forgot I was showing Plotly. I think I have that on here. We'll find out. So we're using 3 other packages now to do this. And so this is, we're using the tidyr package, the ggplot2 package. ggplot2 is something we'll be spending more time on later. I can't remember what month we were going to do the ggplot stuff. But so ggplot2 is kind of the de facto standard for data viz in R. And so it does more complex visualizations a lot easier than you can using sort of these base R functions. And so what I'm going to show with this is, let's go ahead and run this whole thing up to here. Oops. And then let's, so what I did here, I'm just going to talk about it. I'm not, this is getting to some little bit more advanced stuff. So the tidyr package is another one. Well, actually, tidyr and ggplot are both Hadley packages, and other people involved too. But so the gather function comes from the tidyr, And so what I wanted to do is I knew there's these things in ggplot called facets. This is a faceted plot where I give it some sort of grouping variable, and I want that grouping variable, I wanted to create a separate plot for each of those groups or each of those facets. And so in order to do that, I know that I need to have a column with my facet and then a column with the values that are going to get plotted. And so in this case, what I want to do is I want to look at the distribution across a number of my different variables on the same plot. But in my original data set, I had a column for chlorophyll, a column for phosphorus, a column for nitrogen. So what I needed to do with this was switch it where I had two columns. One column that is the parameter, and one column is the measured value for that parameter. And so that's what gather does. Gather will look across, in this case, it's looking across the 6th through 10th columns here, which are chlorophyll, NTL, and PTL. And then what it does is, well, let's take a look at it. NLA gather. The result is, go ahead, NLA gather. Is a data frame that now has, you can see, give me this data frame, and then I want parameter and value added to that, and I'm going to grab parameter and value from my columns 6 through 10. And so the gather function knows to take the column names and put that into this first one, the parameter, and then take the values that match up with those column names and put that into the value. And so now when I look at NLA gather, 4,870. And so that essentially what it did is it took each of those 5 names, and what were my original 974 times 5, 4,870. So 5 columns, it just turned it into a long format. And so now when we look at this thing, we've got parameter, make this a bit wider. Come on. So now I have parameter and value. And so the PTL, which used to be my column heading, is now its own column. And so when I do the facet, what I can do is I can tell, like, hey, give me the facet based on this parameter column. So I had to massage my data, get my data into a different format, and then using the facet, I'm able to create a separate plot for each of my parameters. And so that's what this is. The result is this thing where I created a density plot. That's what geom density did. Again, this is ggplot. I don't want to get into the details of that today. I'm faceting based on the parameter that I had to create with this gather function. And then I change my labels, and we get the resultant looks like this. And then another one of those things we're doing just because it's cool. Plotly is a JavaScript library that lets you do interactive visualizations. And there's been a library, the Plotly library, that was written around that. And it will take a ggplot object and turn it into a Plotly plot. And so what we did here is not trivial. It's not a lot of lines of code, but it's not a trivial thing to understand how to do that stuff. But once we get that figured out, it is pretty trivial to turn it into an interactive plot using the Plotly library. We just wrap that object, that ggplot object, the dense gg, in the ggplotly function. And when we do that, let's zoom this out. It turns it into an interactive. You can see now I'm scrolling over this. It's giving me my X and Y values on there. And then we can do some other stuff. We can zoom in. So I want to zoom in sort of on this, and it zooms in all of those in that area. So we can look at that. Reset my axes. You can pan around in these things, and it pans based on the. How is that doing that? I guess it's just on. Looks like it's doing it on the column in the row here, which is interesting. You can download the plot as a PNG if you wanted. Whoa, There's obviously something going on with the name, that the default name that's going into this. Ah! Evidently, they were having problems with the download PNG button. Of course, now it won't let me cancel. The folder could not be displayed. Of course not. Cancel. But that's pretty cool. Try to do that with Excel or with base R, and you couldn't. I mean, you probably could, but it would not be a fun task. I mean, including the library calls, we're at what, 9, 8 lines of code. There's a lot going on in behind the scenes in that those 9 or 8 lines of code, but it's pretty cool. Oh, it didn't. Okay, I'll have to figure out why. Get that thing fixed. All right. So then I'll just show. Here's another example of what you can do with the faceting. And so this is doing the facets based on the EPA region. And so essentially what this is doing is creating a scatter plot for each EPA region, and we're doing some other stuff. This is with Geom Smooth, which adds the fit. In this case, it's adding a linear model fit to each of those. So again, this is getting some more of the complex stuff, but basically it's what we've already shown, the scatter plots in R, but now we've taken it a step further. We're using a different package to do some more complex visualizations. And again, we're like 2 or 3 months, we'll be spending some time on ggplot. All right. Oh, I messed that one up too. Let's see, build a scatter plot that looks at the relationship between phosphorus and nitrogen. So we've already looked at scatter plots up here using plot. So using this guy right here. So go ahead and try to build a scatter plot of PTL versus NTL. And then build a box plot that shows SECI by reference class. Oh, that should have just been a period at the end. So remember, reference class is that RT_NLA. So there's a couple examples you can follow up here to build those. There's your scatter plot example and the code for that scatter plot. And then here's your box plot example. So try to edit these lines to get the things we asked for in the challenge. Next month, I think we're doing geospatial stuff. So GIS and R.
Are we gonna need GIS to do that?
No.
I was guessing not.
Nope. It'll all be done with packages, Otter on CRAN. Oh, I'll have to look into on Windows. There may, I mean, on Macs, to see if the external libraries need to be installed separately. So we didn't get through a lot. I mean, we can stay. I'm willing to stay a little bit longer if you guys are, but if you have to go at 4, I completely understand. And then, so yeah, so next month, our next meeting is going to be in 2 weeks, and that's going to be the question and answer. So there's some basic stuff that we want to go over. We can do that then. And then please take a sticker. Sure. And then the meeting after that in October will be the geospatial in our. Thanks. So if you guys want to, if you want to stay till 4:30, those we can go through some of the next stuff, the t-test, and I'm willing to stay.
Is there a class in here?
We have this until 4:30, so we're good. Yeah, we don't need to go. Oh, are there people waiting out there?
Yeah, I feel like they're hovering, yeah.
I thought we had this until 4:30.
I feel like if they had class at 4:30, what if they would be on
Yeah. Let me go check.
Very gung ho about coming to class. It must be a good class.
I thought we had this until 4:30. What is today? Today's Wednesday. Yeah, we're here till 4:30. Well, they can wait.
It's an upper level, that's why
They're all anxious. Yeah, so we're good till 4:30. So did you guys get the scatter plot?
Yeah.
Get the box plot? All right, that's easy enough. Well, then we'll jump on to some of the t-test stuff and get to some of the analysis.
A quick question.
Yeah.
So in the basic plot, can you change the axis or do you have to switch to GG plot?
No, you can do all that in base plot. But my as soon as, because those questions never stop. Okay, well, I've changed the name of my axis. Now, can I change the title? Can I change the color of the title? Can I change the color of the points? And then you start to get into more like, that's more the tweaking of the plot. And so for some of the quick things, I still find base plot and box plot and histogram just to get something up on the screen initially. But as soon as you start, because then you're thinking about more of a final production quality, maybe not, but something you want to show somebody else. And so then I think it's worth it to move to ggplot at that point. It's all right. T-tests. T-tests are boring, but everybody loves t-tests. So if we want to do a t-test we can do it with the, say, NPL, and oops, we can use the formula way to do this with Lake Origin. Is there a big crowd of them out there? You tell them to leave?
No, they want to do Rstats.
Bram, come on. All right, so then if we want to do the t-test, we can do that. Let's so this, again, it's using that same formula. Y is going to be the value that you're wanting to look at the mean differences for, and then Lake Origin is going to be the groups that you're going to work with. And when we do that, we get, it spits back. We get our t statistic, our degrees of freedom, we get our the p-value, and then you get the means between the two groups. So yes, indeed, the means between these are different. But again, we also know that there's probably one value that's way out in wacky world with the natural that had a really high nitrogen. So that is very likely driving a lot of this difference here.
Can you throw your log in there like you did?
Oh, yes.
The same way?
Did I do that on the example? I can't remember. And so in this case, now these are still shown up as significantly different. Although the mean, now they're looking less so.
Because I've been making a log column and just running the log column, but it's waiting.
You can do that. It's.
But it's a log that's less efficient. I feel like maybe not.
I think it's probably a 6-1, half dozen the other kind of thing, where you can go one way or the other. There is another way you can do this, but this requires us, I think, to do a little more tidy R stuff. And so before we used gather, remember it took the multiple columns and gathered them into 2 columns. If you have 2 columns that you then wanted to spread out into multiple ones, then you can use spread. And so in this case, what we're going to do is take the lake origin column. I'm actually blanking on how this is going to turn out. Let me take a quick look here. That's the way it is anymore. Hold on. Let's go ahead. So yeah, so what we had before was lake origin was a single column, and so what we want to do now is get the SECI for across those two classifications. So it takes all the values that were man-made, and it creates a column for those. And now you can see I've got a bunch of NA values in here. Because basically, and then you can't have a single lake that's both man-made and natural at the same time. So that's why you're seeing those. But now we can do, this is if you have two separate, say you had a control, you're doing some experiment, you had a control, and then you had a treatment. And so you'd have your measurements on your control column and the measurements for your treatment column. So if you have two columns, instead of doing the formula, you can pass it like this, NLA, man-made, and NLA $ natural. And I get an error. Oh, I think I need quotes around that. Hold on, let's see. Oh, you know, that was giving me problems before, and this is how I solved it. So I just renamed those two columns because the hyphen and the man-made was causing issues. That's from TidyR. And let's do this one down here. We do those names, and then it gives us that same result. So there's two different ways to do that. And then what time is it? 4:18. We should probably go so they can get in here. Yeah, they are. They're going to get mad if we stay in here any longer. All right. So now we're going to go ahead and stop